Welcome back. This week we got a just a short lecture. It's covering mapping and information systems that are used to record and display, basically, where your infrastructure is within regards to your city. Let's dive in. So there's different types of maps. You've got maps that are going to be, typically start out as comprehensive, meaning like it shows you the entire area. You got plan and profile, more for like construction or as-built, and then you got valve maps or hydrant maps, um, commonly referred to just as maps, and those kind of show you where to find the infrastructure that you are looking for. So anytime a developer or there's a capital improvement project or you're making any kind of upgrades to your system, it all starts in the engineering department, right? They typically have the most accurate records as to what is in the ground, what, has been in the ground. And then as they, typically a developer or even at an agency, you're hiring somebody who's going to put together the plans. And then, you're going to plan check those. But, and then you're also looking up what regulations apply. Like, there's sewer lines or storm drain lines that are going above a water main, and so in that case, does it need to go to DDW or Department of Public Health, for approval? You're also looking at easements. Easements are a big deal. Those are what give you your rights, and you have to, people like there's prior rights too. So it's like somebody who got there first and claimed their rights to it typically gets to do whatever they want. And then you have specific rights or specific easements that people can get access to your easements if you have the prior rights. And then anyway, you got to research all of this stuff because it's really important to have that all documented on your plans as you're putting them together. So plan and profile drawings, they're typically, they use a scaling system called stationing. And the reason they use it is because it's a lot easier to identify, where something is on the plans and how far it is from something else, right? So there's usually a datum point, meaning 0 + 0, 0. And then from there, it scales away from it, and it's usually in a linear fashion. Um, so, for example, here, like you could see, you've got 205 plus 10. So, what that translates to is 20,510 feet. So, you can see why they would want to use, a stationing system because these numbers could get pretty big. And it's you have a greater chance of causing error if you're actually just writing out the number in feet. So the stationing is just a visual tool to, help you prevent or help prevent the contractor from making some kind of an error. Um, so we'll dive into a little bit of that math here in a sec. All right, so here's a quick problem on stationing math. You are going to see a couple problems like this, either in your homework or quiz, final, but it's really easy, okay? Let's just dive right into this one. So if you're asked what's the distance between station 345 plus 10 and station 210 plus 50, really all you need to do is remove the plus symbol, right? So in this case here, you could remove that plus symbol from both of those, and then you're just subtracting, the 21,050 feet from the 34,510 feet, which the answer would be 13,460 feet. However, your answer will likely look like, you probably will be given this option, but the more correct answer would be 134 plus 60. So just something to pay attention to. So on your as-built drawings or your plan drawing, you're going to have two sets of plan or views, I guess. Um, you're going to have a plan and profile, right? So plan is just looking down on top of it, right? So you're just looking down. It kind of makes more sense when you're looking at it that way. Your profile would be is if you cut away the earth and we're able to look at your facility from the side. So if you look at this example here, you've got the same information on both of these. It's just a different view from it. Here we have a more close-up view of the plan drawing, right? The plan view. Uh, and you can see in here, if you look real closely, you can see that there's that stationing in there that's calling out, where these are located, right? Where are these service taps? So there, if you follow that line right there, it's telling you where on the main is that service lateral for this one right here located. There's other identifying information, like I could see there's an end cap here. We've got a storm drain crossing here. Here's a fire hydrant. This green line represents sewer. And so you can see, they've got a sewer trunk that flows through here. Even on the main itself, it should be calling out what size main that is. That print's a little small for me, so I can't tell you exactly what it is right now. But typically, these are all printed out on 24 by 36-inch sheets of paper, or they're uploaded into, some kind of program or Adobe that you can zoom in on. Here you've got the profile view. So basically, like I said, you've cut away that piece of the earth, and so now you can see your system here, right? So as that main comes, here's that fire hydrant that was pointed out. Here's that end cap, and here's that storm drain crossing. And you can see that, whereas on the plan view, it was a straight line, but now you could see that nope, you've got angle points in here that are called out. And then in addition to that, you've got those same stationings for the service laterals on this one, but you could see that, both plans provide a clear picture. And then lastly here you've got, a detailed sheet, right? And this is going to show you either the agency's standards or drawings and, standard specifications that they require for certain appurtenances to be installed. But then you also have, like this crossing here. Again, we get this storm drain that, was crossing our pipe, and you saw that you had to go down. But now here's more of a detailed drawing. You're typically calling out, in this case they didn't, but in most cases, you're going to call out these lengths of pipe. I could see that these are restrained mechanical joints, and typically those are going to extend beyond these angle points. Um, Here at the fire hydrant, you can see you got the pipe, the 6-inch pipe, you got a 6-inch gate valve. You're going to call out this length of pipe in most cases. The 90, the riser, your fire hydrant. But yeah, a detailed sheet that's just going to give you all of that more pertinent information that you need to install the infrastructure. Obviously, there's a lot of different types of map symbols. In this case here, these appear to be the SD WAS, San Diego WAS, or Water Agency Standard Drawings. And it just, here's the symbols, right? You've got an air vent or air valve, what they're calling it here. You got an automatic air valve, you've got combination air valve, right? So there's different symbols. Every agency might have their own specific symbol, and it's just a matter of researching that so that way you know what you're installing. A comprehensive map is going to be a map that shows your entire jurisdiction, that where your agency's boundaries are. And it's not going to contain a whole lot of detail, but it is going to be in a scale from somewhere between 500 feet to 1,000 feet. And it likely has like a grid pattern drawn on there. So that way you can look at the comprehensive map, see, kind of where you need to go to, and then pull up that grid and be able to get more detailed information. So that's a comprehensive map in a nutshell. Here's an example of one. And you can see it covers a large area, and you've got a couple reservoirs in there. You can see that, a lot of the time these two different color, these are all water mains in here. However, they're different colors representing a different pressure zone. So you could see how that system is laid out in that pressure zone. So everything in red here is, for this pressure zone coming off of this reservoir. You've got this blue in here, and a lot of times that, you got another reservoir right here, which is probably feeding that zone. You could have other ones in here if you have pressure regulators, breaking it down. I know at VID we've got a bunch of different zones, and so our map has a bunch of different colors. Sectional maps, yeah, these are, typically stored in that book. So like that grid that I was talking about, right? So another name for it would be a sectional map or grid map, and it's going to contain like everything you need to know in that area. It's going to show you where the main is. It's going to show you how old the main is. It's going to, what type of main, and then it's going to have addresses, account numbers. Typically, it's a small map, right? Or it's so that 50 to 100 foot per inch range, is how it's scaled. But that's kind of information that you're going to find. You're going to find, like I said, fire hydrants, more of the details. Here's an example of that. Here, you've got this grid, and then within that grid, you can see the different lots or property lines. In here, these black dots, these are all your services. Looks like you got a fire hydrant here, two services here coming off of a single lateral. Anyway, yeah, there's just, valving in here. You're gonna have, those details that you need. So if you have a main break, you're gonna be able to see who's affected, how do I shut it down. Um, the only thing lacking on this would be like longitudinal lines, so you would know which way is it flowing. Is it uphill, downhill? Because that can impact how you're gonna drain it or fill it. The valve and hydrant map. It's something that you guys will take out into the field with you and have on your trucks or, wherever. And it's going to show you where all your valve hydrants, blow offs, air vents, everything, the appurtenances that, your system has. And then the scaling on it is going to be much shorter. Again, we're getting more into the details on these things. But like in this map here, for example, I could see, like a lot of these dots represent the fire hydrants in here. And I'm sure if you zoomed in, you'd realize that, there was valves in there and where to find those. But again, it's just another map that's super helpful for you to perform your job. And another like detailed map here of your valve and hydrants. Looking at it here, you can see you've got CMLC. I can't quite read what that is. It might be 20 inch. And then the system, splits here. You probably have a valve going off of one way, and you can see you got fire hydrant. It's just, again, it's a detail that is helpful, um, in for you to be an operator and, make sure that you're closing and opening correct valves as needed. I have another really good example of a valve and hydrant map. It's got a lot of detail on here, which can be really helpful. So when you install stuff, a lot of times you have to do 3-point stationing on it, meaning you're taking a measurement from a fixed object. So like a telephone pole, a sewer manhole, a monument, markers that aren't going to move. And, because if you're measuring things based off of a tree or if you're, some other object that, has the more high likely potential for it to be, cut down or removed, you're going to lose that dimension. So other information in here, you can see they're calling out closed valves. That's always good to know because you know that those are, two different pressure zones in there. You got street names, you got the different, you can see that it's calling out the type, size of the main, the type of the main. The water table here will give you more information on those mains. You got a little vicinity map, so even though this is really zoomed in, and you do have the street names, it's nice to have like this vicinity map just to show, give you that real basic information that really helps you identify where you're working at. Again, Everything that we've shown you so far, this is all records, right? These things are maintained in perpetuity. They're never going away, right? You want to keep that information because it can be vital to future upgrades or other development work, where somebody needs to come in and make some improvements and they don't want to hit your stuff. Um, so you do have equipment and material records, right? So they're and it's just that everything that we've discussed so far, it's just, we're maintaining a record of everything. Some agencies have a valve crew, most of them should, and they're going out there and they're turning all the valves that you can see here in this image. They've highlighted what's in, blow off air vent, where the valve is. This looks like a sidewinder. Um, I could be wrong though. Maybe it isn't. Um, anyway, they've called out the number of turns on it, right? And then usually there's a date associated when the last time that was turned. You can flag it for any kind of notes, to identify that, hey, maybe this valve didn't turn the number of turns that it should based on its size, and we need to replace it. Meters are also super important. Most of your billing is based on the size of your meter. So knowing, the make and the model and the size, when was it installed, where it's located, this is all records that every agency should be maintaining on every meter. Other information, obviously tech manuals. If you have a pump station, there's going to be O&M manuals. You've got water quality equipment, same thing. You're going to want to have all these records, and then it's kind of nice to have a backup set, offsite from that location as well. So keeping all of this on computer systems, and then hard copies out in the field is typically what's done at most agencies. Like I said, computerized, right? Obviously, ease of research, being able to pull up this information and find it much more readily and quickly is always a good customer service approach. But that isn't always the case. I mean, most agencies have been around longer than most computer systems have been around at their agencies or cities. So, you probably have a lot of records that are really old stuff. But we all are moving that way, obviously storing everything on the computers. So yeah, computer systems are great for finding information on your infrastructure. Different types of information systems, um, automated mapping, facility management, and then GIS, geographic information systems. All of those can be used to collect and store information on the infrastructure. Um, you have modeling that can be done. So anytime somebody proposes some kind of a development, you have to run it through a fire flow analysis. And so you need to have modeling that can demonstrate that, if there is a fire that occurs in this proposed development, is there enough infrastructure in place to provide that fire hydrant with, let's say, either, whether it's the 1,500 gallons, 2,000, 2,500 gallons, whatever the fire department deems is necessary to fight a fire in that area. So that's what a lot of this information is really useful for as well. A little bit more, yeah. Most of you guys are somewhat familiar, if not a lot of familiar, with the GIS systems and how those work. But basically, it's just a geographical location, or geographic system of the information that is present at that site. And a lot of them are web-based, so you can view them out in the field. They're searchable, scalable. It, super helpful. Yeah, I think that it's real, these systems just keep advancing more and more. I know at my agency we use Esri, or ArcGIS, and that's the system that we're using at VID. So yeah, the other thing I didn't say about is that, yeah, with GIS, there's definitely layers to that system. So you don't have to look at everything that's out there. You can isolate it or you can filter it, excuse me, to what it is you're really trying to see. I mean, are you just trying to see pressurized mains? Are you just trying to see abandoned mains? Are you trying to see certain pressure zones? Are you just looking for services, hydrants, etc. Blah blah blah, right? So you can, the nice thing about GIS is that you can really fine tune it into what it is you're trying to look up. Here's I think a really nice example of a GIS system. Um, just a little side question as you're looking at, all of these water mains on here. Is this a grid pattern? Is this an arterial loop? Is this a tree system where there's, a ton of dead end mains? Um, anyway, just a little side question, but it looks like honestly it has a little bit of each. But yeah, they've got, it's got a legend over here to identify, what is what on this map here. That's a nice little GIS map here. And then you can zoom in on it and get even more information. So if you did zoom in on it, you'd find the customer information. By clicking on it, you could, pull up all kinds of information. And then here, again, you can turn on and off layers as needed. Just depends on what it is you're after. Hydrant information, pipeline information. Obviously, these are all good, good things to know. Especially if you have a main break. What type of pipe am I dealing with? Oh, I got 12 gauge CMLC. A lot of times they'll show you, you're installed here, 2014. So hopefully you don't have a main break on something like that. It's still relatively new. Pipe size, 8 inch, right? Then over here on fire hydrant information, where is it located? What other information, what system is feeding it? Like in this one, pressure zone, they're calling that out. What's the site elevation? So anyway, there's all that information for you right at your fingertips. So, in summary, yeah, there are a lot of different types of maps. They all have a specific purpose. There's tons of information stored on them, which is great for future needs, right? So, if you are ever tasked with updating information on it, you want to be as thorough as possible and provide as much information as possible. It's only going to help out the agency in the future and yourself if you're the one out there having to deal with it. Being familiar with symbols is really helpful. You want to know what you're looking at. Knowing how to read stationing, is really helpful. And then just having that understanding that, there's multiple layers to this, like a GIS system. So if you're not seeing something that you're looking for, maybe that layer isn't turned on. And something, that's something you need to take into consideration. All right, that's this week's lecture. Have a good week.